we obtained from two evacuation grids and the possibility to simulate these kind of behaviors that we found. So, just a review of my presentation. First, there is going to be an introduction about the specific features that trains high-speed trains can have. After that, there is going to be secondly data collection. The drill one is an announced evacuation drill, and we analyze the different parameters about the movement phase. And then the second drill is an announced evacuation drill, and we analyze the response state of passengers. After that, I'll show you some results of evacuation volume analysis, and finally, conclusions will be presented. Well, this morning, Professor Passer, I was talking about the design of behavioral scenarios in transportation systems. He was talking about trains, passenger trains, but we can find different specific scenarios in passenger trains. I saw two presentations today about the trains, about passenger trains, but we can find that there can different passenger trains. In this case, high-speed trains are quite different than metro trains or commuter trains. So you can find these different specific features. Variety of potential scenarios. We can find variety of potential scenarios in all passenger trains. The fire breaks out while the vehicle is still operating, or maybe a collision or derailment. You can find these varieties of potential emergency scenarios in all kind of trains. So passenger trains, high-speed trains have separate coaches. This is quite different than, for example, some kinds of metro trains. And there can be a few crew members, but at least you can find one crew member in high-speed trains, or two. But it's 1 or 2 crew members for at least 400 passengers. So it's quite difficult to manage evacuation for so many people. And high-speed trains are simple geometries with narrow spaces. In fact, this is a special feature of high-speed trains with a long aisle and seats in both sides. The interaction between passengers, between the behavior of passengers and the movement of passengers may be very high. So the main focus of this presentation is to find in these preliminary findings, to obtain data about how passenger behavior affect evacuation, what are the main behavioral parameters in this kind of scenarios, and when passenger behavior is determinant, and which factor affects the passenger behavior. So I know it's very wide objective, but I try to explain some key points about the passenger behavior in this kind of environment. This is the first evacuation drill. You can see the evacuation procedure is performed by Red Operadora, the Spanish Railroad Administration. And we have the possibility to locate 2 still cameras in the passenger coach. The procedure was consists on fire in coach 4, simulated fire in coach 4, and the crew members. The evacuation strategy consists on evacuate as many coaches as possible away from the fire. This is the practical that they used to make in Spain. And all passengers from these coaches can evacuate as far as possible from the fire, and passengers from that coaches go to coach 1 and 2. We can locate the 2 still cameras, as I told you, here in coach 9, and here between coach 9 and coach 10 in the vestibule in front of the exit. So this is movement analysis. We don't collect data here about the passenger behavior because the evacuation evacuation procedure was generates that passenger coaches 9, 10, and 11 was crashed. So we can find different data about the pre-movement times of passengers, because they don't have available space to access the area in these conditions. And then they perform the evacuation to a platform inside the tunnel of Guadarrama. We don't analyze here the specific conditions inside the tunnel, just only the specific conditions inside the vehicle. So we measure firstly the flow through the ice when the relocation procedure strategy is performed. We measure the flow rate of passengers at certain point inside the car. So we have found that there was 4 different stages in this graph. You can see 4 different stages that correspond with different passenger coaches. The average flow rate obtained is 24 persons per minute. This is a value really lower than value established by ATOC standard. ATOC standard is 14 persons per minute. So they do not take into account the response of passengers in these coaches, because the train crew is telling them, come on, stand up and go to the next coach. So the other passengers, for example in coach 6, remain seated, waiting for the train crew instructions. And we obtain also the walking speed, the mean value of 0.99 meters per second, and the standard deviation of 0.20 meters per second. It's quite lower than the walking speed in unlimited walking speed, obtained from the literature in another environment. This is because the aisle is quite narrow, so people try to, and people was walking in the queue conditions, so they keep enough distance between them. But we believe that this reduces the walking speed of passengers. Now here we obtain data about the flow through the exit door. And the main point here is that the flow may be changed. It depends on the different trains, the different scenarios. The platform level with respect to the train level may be changed, even in the same train. The same train can stop in a station. In a station, the platform maybe have the same level with respect to the train floor. The same platform. This is because and even you will find different trains with different train steps. So this has to be taken into account, because we are calculating the evacuation conditions in this kind of trains. So in this case, the train steps was 25 centimeters ahead, and the gap was 40 centimeters. There was a step here. But this has a quite impact in passenger behavior when they negotiate the exit. You can see here the variations, the time spent by each passenger to negotiate the train steps. You can find here how weak people have difficulties to negotiate the train steps. So this has to be taken into account. The flow may be different from buildings. It's necessary to measure different flows in different trains and different conditions and different scenarios. 2 of the papers here presented here have analyzed these different conditions with respect to the height of the train floor, with respect to the height of the top balance for the platform. Now, here's the second evacuation drill. This drill was not previously announced. There was a catering test inside the train. Most of participants